I was hoping that we'd be able to generate up to 250 millivolts, but without cooling the opposite side when I stick it in the wood stove, there's a lot of heat hitting these opposite cool sides and not allowing a great differential in temperature between the two sides. But you can see here we just have the cold sides on one side, we have our hot points all sticking out on the other. I flattened them all together into one big chip here, and that should produce about 200 millivolts. I'll show you that just here in a second. Alright folks, so I've got that thermoelectric cell that I showed you just a moment ago. It's sitting on a metal shovel here so I can put it into the wood stove. You can see the wood stove in the background in there. That's nice hot coals. It's radiating a lot of heat out of there, and already, since I've held it up there, you can see the meter's already climbing. So we're at 17, 18 millivolts. Let me go ahead now and lift it up into the firebox. We're going to set it in there and go ahead and watch the meter here. So already we're at 40, 50 millivolts going up. 70 millivolts. Already at 80. Any moment here we'll pass the 100 millivolt marker. So right now the very end of all those cells are in the fire, and this outside end of cells that you can see just behind the meter there, if I bring the meter down a little bit, those are getting cool. Now they're not very cool compared to what they would be if that was outside on the stovepipe. So if you notice, it's starting to really slow down here. If we can get it nice and hot in there though, it'll get up to about 200 millivolts. Like I was saying though, once we stick this into a stovepipe section and get those outer tips much cooler. Right now those outer tips are actually being hit by a lot of the heat coming out of that stove. So they're not creating a huge differential in temperature between both sides. Once that differential is increased, let's say it's 30 degrees outside, and that inside of that wood stove pipe is being heated up to 400 degrees, there's a very large differential. And that differential will produce much higher current flow. So right now it's starting to smoke in there since I have a wood band around the thing. This was just a test to show you what an iron aluminum cell could do. I'm not going to waste any more time on this cell. So we're kind of getting up here 184 millivolts. Now if I could cool these outside points here with some kind of fan or something like that, you'd watch that rise even more, and we should get up to 250, maybe 260 millivolts with this combination, with a light fan or breeze blowing against this outside edge of those points of these thermocouples. So 190 millivolts here, and this meter doesn't test amperage, so I'm going to have to hook up a different meter, take it out, let it cool down a bit. I was just going to let it get up to full temp, let you see what it can produce. Well, any further, I'm going to start burning the system, so let me go ahead and pull it out of there. You're going to see a bunch of smoke coming off of it. So there you go, folks. We were able to jump up to about 190 millivolts, and you can see now it's already starting to go down.